Good morning, everyone. Welcome to the next Cluster Life Science Kraków breakfast, which is actually a life science innovation breakfast today. So, medical data is one of the most valuable resources in the healthcare today. It can help us better understand diseases, evaluate treatments, and improve patient care. However, much of this potential is still not fully used because data is often fragmented, difficult to access, and stored in a system that do not easily work together. So today we will explore how healthcare organizations can safely unlock the value of medical data without moving it outside their own system. So my guests today are Bartłomiej Kosiba, EPAM Kraków site lead. Hello, Bartek.
Hello, good morning.
Sarah Seager, Senior Director of Business Development. Good morning, Sarah.
Good morning.
And Sajan Madpedi, a Lead Scientific Creation Specialist. Hello, Sajan.
Yes, hello, very good morning.
I hope this will be a valuable meeting for all of you. And also, I invite everyone to take an active part in the discussion. And now I would like to give the floor to our guests.
Okay, hello, Bartłomiej Kosiba. I'm playing a role of Kraków site lead within EPAM. And today I'm going to briefly present EPAM in general and shortly about EPAM in Poland and in Kraków. Sarah, let's move to a few slides ahead. Let's move to the EPAM Poland, to the EPAM general. Okay, so EPAM founded 33 years ago. We are at the moment nearly 63,000 people across the world. 57, almost 57,000 people of that are engineers, designers, and consultants. We operate in 55 countries, which makes us one of the most geographically diversified companies. We have a steadily growing revenue. At the moment, last year reported $5.45 billion. This was, I believe, some 15% increase year over year compared to 2024. When it comes to sources of those revenue, this is healthy, diversified across different industries. Life science being at the moment quite small, although I believe this is one of the fastest growing when it comes to internally growing within EPAM. Geographically, revenue is also diversified across Americas and Europe. APAC is slowly gaining up. Let's move to the next one. When it comes to geographical diversity, right, we operate across all of the time zones with a healthy coverage with a healthy split of coverage between those. India at the moment is one of the fastest growing. Poland makes a strategic location for the whole EPAM with almost 7,000 people. Let's move to the next one. Our history is organic growth, starting in that 1993, since 2012, where we are not registered on the New York Exchange. We are also going through some acquisitions and mergers. And those are strategic ones where we want to get into specific geography, where we want to gain some specific capabilities or specific kind of talent. I think notably from this list we have Odysseus here 2 years ago, which makes us being able to be here today with Sarah. Although, right, those are diversified with technologies, with consultancy, with specific skill sets. Let's move to the next one. When it comes to EPAM Poland, we operate in mostly 4 cities, Kraków, Gdańsk, Warsaw, and Wrocław. Those are main locations with 90% of our headcount. At the same time, we are diversified to use smaller locations to be able to leverage talent from those locations. Of course, we do have all of the relevant management system certificates, notably ISO 13385 for medical devices, where we're certified for physical product design in Gdańsk and software development in Kraków. Let's move forward. History in Poland that started in Kraków 2011 with only one small office and serving one financial services client. That grew organically quite fast, allowing us to open also Gdańsk and Wrocław delivery centers, where we actually started to deliver not only specific people to specific clients, but rather start to own projects from start to end. Over the years, we've also did some acquisition within Poland, Informatic, Polsource, with large Salesforce headcount, with a steady growth over the years. With 2022, when we had a lot of, you notice the high spike in the headcount, that's where we had to relocate some of our staff from Belarus and Ukraine after the election in Belarus and war breaking up in Ukraine. And then we continue expansion and growth to today with the latest acquisition globally of First Derivative, but it also contained a few people within Poland. First Derivative is actually consultancy within financial services. When it comes to what we're capable in Poland, starting from the core competencies like core engineering in various programming languages, specific parts of the software delivery process, business analysis, quality engineering, throughout cloud specialization, going into big data and data analytics, together with having AI solutions implemented over them, with any digital engagement, driving also some external marketing campaigns, and going through embedded and Internet of Things items with our garage makery labs in Kraków and Gdańsk locations. We also have capability to provide architecture overview and full end-to-end delivery and project management out of Poland. Let's move further. With recent changes, right, AI is everywhere. We're transforming ourselves with AI Run Transform program. This was launched beginning of last year. This serves us as a force to drive ourselves and also into providing those transformation services to our customers. Let's move further. With that, we also have a specific workforce out of Poland with a small but still significant implementation of AI-driven solutions with over 100 cases delivered last year. I think I need to speed up a little bit. So let's move quickly with the few next slides. We partner with universities within Poland, multiple ones, Kraków, specifically with AGH and Politechnika Krakowska. Let's move further, where we deliver specific courses, but also are consulted regarding the curriculum for the upcoming years. Let's move further. We provide quite a lot of internal and external communities within our offices. We have a quite nice dedicated space in Kraków specifically for such events. Some few notes, right? We're running like hundreds of events across Poland with those, including also external like Azure groups, generally Kraków, Sitecore users, etc. And apart from that, after work hours, right, we care about local stuff like environments, supporting nowadays also seniors with some basic literacy skills in technology, supporting companies with our technical expertise and application development like Mocni Pomocni, and all other stuff that I could spend probably next half hour to describe, but I believe we should actually move to the core of the meeting. Back to you, Sarah.
Thank you so much. So I will start to talk about essentially our life sciences and healthcare capabilities across EPAM, and then I will move into sort of what we're here to talk about today, which is our real world evidence business unit. So high level, our life sciences and healthcare practice, it essentially forms 11% of all of EPAM's businesses. It covers sort of 12 out of 15 of the top life science companies. And as you can see, there's an array of various clients that we serve with our various offerings that we supply from the business unit.
Halo, dzień dobry, mówi Renata Zaręba, firma.
Going into EPAM real world evidence. So essentially our EPAM RWE, it's a subsection.
Dobrze, spokojnie. Dziękuję, kłaniam się, do usłyszenia.
It's EPAM RWE is a subsection of our healthcare life sciences unit, and about 2 years ago, we were a company called Odysseus and acquired by EPAM, and essentially we were brought in because of our real world evidence expertise. And what we sort of our core offerings is really around sort of standardizing real world evidence at scale. So what does that mean? Essentially that means we are taking various forms of real world data. So that's usually data from electronic health records, it's claims data, it's registry data. And what we do is that we actually then standardize that to a common data model. We have lots of other services and offerings that we do as part of real world evidence. So not only are we looking at data conversions and standardization, we also undertake what we call our healthcare ontology service, where it's looking at the clinical ontologies, the clinical coding that is within that real world data. So because we are working on a global scale, we are dealing with data from across the world, various countries, various languages, but also it's the clinical ontologies. So we have an expert team based over in Eastern Europe who specialize on actually mapping those clinical ontologies to the common data model. We have a strong engineering arm, as you would imagine, from EPAM, but we also actually have a data science offering where we are doing clinical retrospective observational research. So we are actively using the real world data that we are handling, and we're actually analysing that data to essentially produce what we call the real world evidence health insights for a particular number of sort of studies. And then we also have our healthcare data network. So I'll go into a bit more detail of each of those and to what they offer and sort of who we sort of talk to. But this bit at the bottom right, you will see it says here that we are an active member of this open science community. Now it's called Odyssey, so pronounced Odyssey, but it's OHDSI. And we've been part of this clinical scientific community for a good 10 plus years. And essentially this is where this common data model stems from. So what is Odyssey? So as I mentioned, it's a big global open source, open science community, and it has a real mixture of multiple stakeholders. So we're looking at academia, we're looking at life sciences, you've got tech organizations like ourselves, you've got health systems, you've got patient payer providers, and they are all part of this scientific community to help and increase the awareness of this common data model. So the common data model itself has a name, and it's called OMOP, so OMOP, and that is essentially what we are standardizing our data and our vocabularies to. Now Odyssey's been around for about 15 years, and as I mentioned, it's global. It has over 4,000 global collaborators. There are a number of work groups, so everyone's contributing in their own way. And the OMOP standard, the OMOP common data model, is actually now one of the top, if not the top, common data model, standardized model that is being used across all of healthcare, across all of pharma, and it's continuing to expand. So on this slide, you'll see that there's even the regulators. There's a global regulatory adoption of the OMOP common data model. So over in the US, it was actually the FDA who 15 years ago, I think it was, maybe even 20 now, actually put a call out to say that what is needed and what is missing is essentially this standard healthcare system where we can potentially start looking at a lot of the various data sets, the data sources across all of healthcare and life sciences, and to try and somehow leverage a commonality so that you can actually leverage real world evidence. And so because of that call that the FDA put out, that is why and how the OMOP common data model came about. It was in response to the FDA's request of having this global health surveillance system. So across America, that's expanded further. There's the All of Us research program. The CDC has adopted OMOP as well. And also across Europe, there are a number of networks, but specifically from the regulatory perspective, it's the EMA, the European Medicines Agency. They are absolutely on board. They have even announced that OMOP is their standard and is being used across most countries, and it's continuing to expand. Over in APAC as well, we have the Ministry of Health that have adopted. There is Singapore, China is very much involved. All of South Korea have their own nationwide OMOP platform. So as you can imagine, with all of this availability of data and being standardized to a common data model, what that means is that you can actually conduct your clinical study against multiple countries, multiple data sets, multiple care settings, all in one go. And it only really requires that one cohort, that one analytical script, because even if you're looking at data in America, or if you're looking at data in Poland, or if you're looking at data in South Korea, your analytical script is talking to the same common data model, no matter where you are actually analysing. So just to go sort of in a little bit more detail, but still sort of fairly high level. I'm not sort of teaching anything today or trying to be technical. So the conversions. So what does that mean? We're essentially, as I mentioned, taking raw data, native data from a number of providers. So as I mentioned, there's claims, there's registry, there's even surveys data out there, omics as well, and even clinical trials are now sort of being supported. And that is then sort of being farmed into sort of what we are calling our OMOP data factory. We are then processing it. We are then essentially standardizing that native data into the common data model. So there's a huge set of relational data tables, and it's then standardized with their terminologies as well. And then that is then essentially you have almost like a second flavor of your data. So if you are a healthcare system, a hospital, you will have your native data, and then you will also have the OMOP version of that data. Data is exactly the same, it's just that it's been standardized, and there is no loss of data here. That's one of the big myths around using a common data model. You do not lose data. If anything, what is happening is it's just being sort of harmonized so that no matter what data set you're looking at, if you are looking at, say, diabetic patients, you know that for diabetes, your clinical ontology is going to be the same for your data, for your neighbouring hospitals' data, or for hospitals over another part of the organisation, of the world. And so from that, you've got your standardized data, and then you can upstream these data analytics. So you've got the reporting. Now, one of the crucial things is that out of the analysis comes aggregated results. So there is no sharing of personable or sensitive information. So it obviously helps with a lot of the sort of governance and data privacy issues that are out there. So as I keep mentioning, there is the ontology, the clinical coding. It's a huge piece, it's an important piece, because it's not just about the data, the tables, it's also about the actual clinical codes, the medical codes that are being used. So one thing that we do, like I mentioned, we have a dedicated team who deals specifically with the standardization of those vocabularies. They're ensuring there is that semantic alignment to the broader OMOP ontology management. With that comes an awful lot of quality assurance and quality checks as part of that piece of work. But what we also do is, as experts within this field and being sort of global coordinators of this broader scientific community, we do actually get involved in an awful lot of vocabulary training. So we conduct a lot of training workshops, there's a lot of tutorials, but we also help and support a lot of our customers with regards to actually upskilling their own teams to be able to do this. So obviously we can do this for our clients. We've been doing it for many, many years. But the beautiful thing is being able to then obviously help with upskilling individual teams. We are EPAM, we're an engineering company, so obviously we have a huge engineering aspect to our offerings. So with regards to the standardization piece, we offer and support sort of the Odyssey platform engineering aspect. So it's about setting up that platform, the architecture for our customers. So it's ensuring that they have the tools, the methodology that they need to be able to do the standardization. We also offer a number of sort of custom solutions as well. So there's bespoke software engineering, the development of particular applications. We assist with sort of workflow automations and all of that. Now, dashboarding, business intelligence, business visualization, again, that plays a crucial piece, because we're not just about the data or the standardization, it's about then the leveraging of that data. It's the producing of the insights. So with that, an important piece is around the visualization. So we've been involved in a number of interactive dashboards. We were able to use and offer a number of solutions from that perspective. And obviously our data science teams, our epidemiologists, they're the ones that are actually producing this and need this to help with getting the customer to understand what the results are from their studies. Data quality is super important, so obviously that goes hand in hand with any sort of data handling. But then we also have a number of our AI-enabled RWE solutions. So we will go into a fantastic tool a bit later, which Sajan will show shortly. But we have a number of AI features that has really helped to actually sort of make a lot of this process a lot more efficient. So when it comes to studies, it can involve a lot of free text information. There's publications, journals that we are looking to sort of research and sort of, get a lot of our learnings from, but our AI solutions can actually take that and turn that into the cohort ready pieces so that our analysts, our data scientists can then get on with the studies. But we'll go into a little bit more later. I mentioned data science. So yes, we have a data science offering. We have a team of data scientists. And with that, there's some statisticians and our epidemiologists. And essentially what we do here is we are working on those large scale retrospective observational studies. We will work across all therapeutic areas. We are able to actually produce and write those protocols, those SAPs, those statistical analytical plans. We've had a number of studyathons across the years, and we also, as part of this scientific community odyssey, get involved in a lot of the sort of the network studyathons and the network studies that are available. Again, we are offering training. We do a number of workshops, so it's about sort of that upskilling as well, but from a research perspective. Now, all of this means and opens up the door for what we call and what we are building our federated data network. So one thing I didn't cover, but this is crucial at this stage, is so we've taken electronic health record, for example. We've taken that raw data and we standardized it to the OMOP common data model. Now, at no point do we ever move that data. We don't need to actually take a slice of that data. We don't need to bring that onto our own premises, for example. We're able to standardize that at the site. Now, when it comes to the analysis, because the data is, as I mentioned, in a common data model, it's in a harmonized and standardized state. What that means is that with our knowledge, our expertise, we know exactly what the common data model looks like. So if we are doing a study on, say, patients with hypertension who also have chronic kidney disease, for example, we are able to actually produce or create that analytical script, that cohort, and then we essentially share that script to the hospital or to our client, to the data partner, and they then are able to run that, execute that against their data. We're not accessing their data. We don't need their data. We can share that script. What then happens is those data partners actually, as I say, run that against their data, and they will then share back aggregated results. It's an output, but there's nothing sensitive in it. So we don't need to worry about GDPR, HIPAA, or anything like that, because again, we are not receiving data. We're not even touching our data partners' firewalls. So because of that, it means we're able to actually create this federated data network. So EPAM, RWE, we essentially are acting as a coordinating center. So we will have our client, say a big pharmaceutical client, they will come to us and say, I wish to do this global study on diabetic patients. What data partners do you have in your network? Now, we are building this continually. It's something I work on every single day. We have various partners across all of Europe, across all of US. We're expanding even further into APAC. So we are working at the moment with expanding this network into Japan and China. We have current partners in Singapore. And what that means is we can then go back to our client and say, yep, these are all our partners. And then we can essentially do a sort of a quick assessment on their data to see whether it's going to be fit for purpose for that study, because it depends on what type of data. They might just be primary care, it could be secondary care, could be a mixture. And if that's the case, great. So we actually act as that coordinating center, which means we've taken all of our other services and almost sort of put them into one pot. And that means that we can then obviously help our customers with their studies, even the regulators, the FDA, the EMA, the NHS, they come to us as well because they want to expand that study, that particular piece of research, and do that on almost like a global scale. Or maybe they're even looking to actually run a study against 2 to 3 data sets. They don't have to own data, because how that network works is, as I mentioned, the analytical code, the script, it could be a JSON, it could be an R package, is shared to the data partner. They run it, they share it back to us, the result they share back to us. We then put that together either in a dashboard or in a written report, however the customer wants it. And that's essentially that piece of research done. Now, to do this, we have actually designed a tool that is called Prometheus. It's our federated data analytics platform. It's able to actually do all of the core analytic modules that we would do as part of any standard study. So it's things like your prevalence rates, looking at your burden of disease, looking at healthcare treatment, therapy pathways, all of that fun stuff. And it was initially designed to purely work with data that has been standardized to OMOP, but in more recent years it can actually work outside of OMOP, so it can absolutely lay on top of any of the healthcare life sciences data that is out there. We've expanded it so that it also has a large library of artifacts that are ready to use, ready to go studies, which is super useful for all of our customers. It has a data cataloging application, so we can actually understand some of the information, the data that is being used on. So those customers that have Prometheus, they can actually start cataloging their own data. And also, as part of that, we have a lot of inbuilt AI accelerators in there. So there is the ability to actually produce your protocol from, as I mentioned, a publication, say from PubMed. So you can go and get Prometheus to go find that publication in PubMed, bring it in, and then it will actually start to produce that protocol for you. And it does the same with all the concepts, the cohorts, the codes as well. So that was super high level, but on that note, what I will now do is pass over to Sajan, who will just show you Prometheus in a little bit more detail, just to sort of show you how that works. So thank you very much for listening. Sajan, I shall pass over to you.
Thank you so much, Sarah, for that wonderful presentation there. So let me share my screen first. So I have a screen here. Share. Suppose you're able to see my screen now.
Yes.
Prometheus there. Okay, great. Sounds good. Let me make it a small here. Okay, great. So now I'll be giving you an entire overview of Prometheus from a high level. So this is the software. So we can use the login, the native login username password, or go with login Microsoft Azure. And once you log in, so this is where you land up. Okay, so this is a Prometheus software dashboard. The welcome home screen would look like. So we have notifications, then whenever an analysis is completed, you get a notification, and if someone is invited for the study, you get the notifications here. And coming to the left panel, you have multiple icons here. You have workspace, you have studies, you have artifacts, data catalog, and vocabulary. We'll go one by one as we proceed further. And the same icons which you can see on the left side is also available on the main home screen for the easy access. And as you can see, there's a search button which will help us to search through vocabulary, study managers, cohort analysis, concept set, data catalog, artifact library. So at one point you can search and start working from where you left. And also there's options of favoriting your studies so that you can easily access, or you can directly jump into creating the cohort, concept sets, or even analysis. Right, so this is how the entire homepage would look like. So let's now jump into the workspace, the most interesting part of the entire Prometheus software. So what so workspace is your private space. So whatever studies, concept sets, cohort, and analysis you do in the workspace will not be available or seen by anyone else. Okay, it's very private, and only you'll be able to have the access to all the data and analysis what you've done. So now let me just okay. So let me just show you how we can create concepts, cohorts, and something about analysis. So let me do think. Let me take you through a manual process. Let me show you once. Let's take into a concept set. Let's create and add a concept. It's a very simple way to create. So I'll take a topic called as a drug, in immunosuppressant drug called as tacrolimus. So which will be creating a concept set, which will be used in the cohort to create the entire cohort, and then that will take into creating the analytics. So just wait for a couple of minutes, then I'll take you through the AI part of the same journey. Okay, so let me take it. Okay, so we have. I'll take this. Okay, so we have tacrolimus, which I added the drug here, and let me go here and again search for tacrolimus domain. It's a drug, and let me search to find that concept in the vocabulary here. Right, once you get that, so we have the tacrolimus here, which is an ingredient class. And if I scroll to the right, so we have record count around 834, and all the information. The domain is drug, vocabulary is RX norm, so all the information there. Right, so let me move to the left and just click on this and add to concept set. So you can see now you have added a concept set of tacrolimus to the concept set here. So you can see one concept set, source code is 56. Now if I click on this, so what is this? This is descendants. It will connect all the descendants. What is? If I click on the descendants, so now the entire thing jumps to having around 2000 concepts, included concepts, what you can see here. And there could be around source codes, around 4000 source codes got added, and that's how you can create concepts very easily with the Prometheus software. Now with ease of use, let me just directly jump. I'll just save this, and from there we can just go to cohort, and we want to create a cohort for tacrolimus, and let's attribute as an initial event. And what is it? It's a drug exposure. It's a drug, someone has taken the drug, and click on add, and now we have created the cohort. So automatically the concepts get added to the cohort, and you'll be able to see the all the. So now from here you can add inclusion criterias, what are the cohort exit criterias, and cohort errors. So we currently will just keep it as a tacrolimus use case. So let's go to the use in analysis, and let's go to use in cohort counts. So we're trying to create an analysis for tacrolimus for the target cohort and see the cohort counts. So let's execute this. And when I click on execute, so this is where Sarah was mentioning about the database, right? So we have so you as an organization would have the data, or your partners have in hospital, or we have EMR, HMS data, and the insurance data. All this can be part of it, which can be present here, and you can select them and then run the analysis on that database where you're creating. And based on that database, this immunosuppressive drug, how many people are using it? So what's the count of people who have been using this drug, will be able to see in couple of minutes. Okay, let's come back to this. So meanwhile, instead of going through all this so now I just told you about a manual process. So let's take an example. Let's take this as an example. So I'm just taking one example from a Lancet, which is already a retrospective cohort study on development of a treatment selection algorithm for SGL2 and DPPH4 inhibitors therapy in people with type 2 diabetes. So now I would want to create an cohort for this, right? So this is the entire study here. We have full study. You can see as I scroll down, there's a summary, then there is a methodology. So there is a method which describes the study design and participants. And if you go through carefully, so you can see there is entry event initiating patient initiating a particular inhibitor therapy. Then there is exclusion, what has to be done criteria, and all the information, the study duration, everything is mentioned here. So this would be the right uh, paragraph for us to describe. It's describing the cohort. What is the group of people whom we are trying to do the study? So now coming back, okay, before we go to the AI part of it, so now you can see there is, if I click on this, so the count is 824 persons are using tacrolimus drugs, and out in this is one database, and this is another database where you can see in this database we have 17,000 people who have been using this drug. So then we can go into more depth of the studies. How can we do it? So now let's come back to the AI parts. Let me just create a simple concept set first, and then I'll show you how do we use this study to recreate this using AI. So let's if I so now let if I want to create an concept on, let's say, on diabetes type 1, right? And let me just give the description as same as diabetes type 1, and if you can give more detailed description, as of now I'll just keep it as diabetes type 1. So currently I am looking into the conditions, so let's keep any concept set, any vocabulary, suggestion from external publications. Yes, you can. So it goes out of in the internet and finds the publications and understands what could how we can define this concept set and what should be the codes to be added. Right now, click on generate. I think it's already, the name is already there, so it's showing that. So I'm just, because I already created, so it will take time for it. So once you click that, now the AI will start working on creating that concept set. So because of the time limit, so I have already created, where is that? What was that? Medications. So all these are, you can see there is a star icon here. So this is, it shows that it's an AI generated concept set. Okay, so let me go back. Okay, here, type 1 diabetes mellitus, which I had already created. So once the entire analysis is done, this is what you can see on your dashboard, right? So you can have expressions. You have insulin dependent diabetes, insulin diabetes, and newly diagnosed type 1 diabetes. Then you have 4 concept sets which has been added, and you have included source codes which has been automatically pulled up from SNOMED, CIEL, Nebraska, and OMAP, and all those things. So you can now go in detail and know human in the loop. So what you want for your study, and you can make it more customized, right? So that's how simple it is to create concept sets with Prometheus. Now let's get on the main part of it, that is cohort, right? So now this is a study which we want to create a cohort for, right? So let's take a treatment selection algorithm for these inhibitors, or let's take this as a name for us, our study. Let's go to the generate. So we're creating a generate, we're generating the cohort using the AI features. So I'll give the name as this, type 2. And for the description, so we have description, we have described this cohort. So now, because already there's a research, and I feel the method or the study design and participants, what explained in these paragraphs exactly matches how I want to create my cohort. I just want to replicate this. I'll just copy this entirely. Normally we would clean that and use it now just for the demo to you to understand how AI efficiently even the cleans the entire structure and gives the output. I'm just adding this completely. And now once I scroll down, okay. So now standard concept set, let's keep it as any vocabulary. As of now, let's keep it as open. Now search precision. So how exact or how broad you want your search to be, right? So that's where you can go to limited to 5 or closed concepts here, and here limited to 10 closed concepts. So let's keep it as 5 here. So let's be a little strict about the how it has to be created, and let's just click on generate. That's it. Now the AI does this magic in Prometheus and will give you the entire cohort creation. So it will take a couple of minutes just because of the time constraints. I already created the cohort. I'll just show you. I hope was that here. Yes. So this is the cohort which I had created yesterday. And once the entire AI does the magic of it and goes through it, the Prometheus, it's gonna give an outcome like this. So you can have the definition, the cohort entry is automatically taken up, the drug exposure of this, and occurrence starts from what date, and the earliest event, and all the inclusion criteria is detailedly added. You can see all the inclusion criteria is detailedly added. So exclude or concurrent insulin use, and it also can see that even the measurements, which are sometimes becomes complex, also has been automatically added, and the entire AI makes the entire workflow very fast, swift, and easy for you to execute your study, right? So now, is it now the entire process is fast tracked by AI in Prometheus. Now, you being an expert, go through the study in detail, and you can cross verify each of this steps and see being so basically the principle of getting the human in the loop and verify and validate what the AI has done is correct or not. Okay, so it almost gives you the exact value as you describe what you want to create the cohort as. And you can also see when you start when we put the cohort creation, automatically the entire concept set is also created along with that, right? So you can see the concept set, which has been around 7 concept sets, has been already created and executed completely. So that's how simple it is to work to create concept and cohort with Prometheus. Okay, and to whatever complexity and extent it is, so the AI would help you to understand and create it. Now coming to AI part of it, you don't just have to blindly believe what has happened. You can see and understand how we have. If you go to the last tab here, it will give you what has happened. So AI reasoning, the step-by-step reasoning of the cohort generation. Why did it generate the way it is generated, right? You can go through it and understand what was the thought process behind creating this entire cohort by AI. So it also becomes a process for a newcomer. So you create a cohort using AI and understand how the AI thought process was to create it, and it becomes an learning pathway and process also. And for experts, it understand, okay, where did it go wrong if there is any mistakes, right? But everything is seamlessly put up here so you can understand. And there's also we also have an access to AI raw outputs, which you can also go through if you're interested in the raw outputs. And that's all about how the Prometheus able to create the raw concept sets, cohorts for the process. Right. So now let's move. So basically this entire process, what I'm showing is under my workspace. So when I'm telling workspace, so this is a private space, only it's my workspace, so it's only visible for me and not visible for others. Now, what if I want this type 2 diabetes study or any study to be a collaborative a study between multiple people? Then you can create or move this into a study place. So study portal, what you can see below here, is a collaborative space. So here, whatever you create, you can collaborate with multiple people, people of who would be working on that research. So let's take this as an example. So Trachylimus itself. So you can see the study, and you can see all the latest activities, who has worked and what they have done. Its timestamp is put, and you can see on the right side, you can see participants, and we can add all the participants here. So you can click on add participants as a lead investigator or a contributor, and who once you have your organization, all the members of the organization will be added here, and you'll be able to send them the invite to join your study. So that is where the collaboration happens when you're creating a study at the large scale, and also when network based studies are happening. And coming to the data source, so what are the data source from the multiple hospitals, or the EMR data, or HMS data, or insurance data, the claims data. You can, if you have it, you can click on add source, and if it is already uploaded into, we can upload it to the Prometheus, and you'll be able to, so you can connect to the Prometheus. You don't have to give the data, it's just connection. So you have to connect the Prometheus, and you'll be able to access the data through Prometheus, and the data is completely with you. The Prometheus software is just giving you the analytical tools and processes to analyze the data. Okay, so that is where you can connect your data sources to here, and any documents what is required for this particular study can be stacked here, so that it is accessible to all the participants, right? So that's how the collaborative process works. So other than that, the concept set structure, the cohort structure, and the analytics, everything remains the same. Okay, so there is no difference between how that works. Just a minute. Okay, now let's see here. Okay, so let me try to see this analysis. Oh, analysis, right. Results, if I have any results to show you. Right. So I'm just showing you how the results would look like. So this is characterization atopic dermatitis, and this is how the final results of analysis, once the concepts are created, once a cohort is created, and you connect it to the database which you have got of EHR or claims data, and when you run the analysis, this is how visually you can see all the analysis of the data what you have in the demographics, age groups. So I think there is 100 plus analytics what we have been already pre uploaded to it, so you can use all those things to analyze and get the desired outcome of the study what you're looking at. Okay, so let's close this. And I think okay, so let me just give, that covers the study part. So studies is a space where you can collaborate with any number of people. Now coming to the artifacts. So when you create a cohort, and when you create concept sets, and if you feel that is something at a gold standard where anyone can, you want others to use that gold standard and hypertension cohort or a concept set to used by entire team. So that is where when you can publish it. And so for example, I have submitted, you can publish it, and it comes to submissions. The submission happens, and it comes to the artifact library. From here, the entire team members, the organization members here can reuse that to different studies what you have. Okay, and that's all about artifacts. Then let's get into the data catalog. So this is where we connect all the databases what we have. And if I just get into one of the database here, so this is all, of course, synthetic data what I'm showing now. So you can see utilizing statistics. So when you take EHR data or the claims data, and so when you're getting that data from different organizations, here this is a dashboard which can show you who are using it, like by users, who are using this data in your organization, how efficiently they are using these data, how many studies have been run using these data, and right. So basically, the return on investment for the administrator is this dashboard where you have got so much of data, and are these data has been effectively used, and who are using effectively, and how many studies have been done using this database. Is something what you can see in the data catalog. Then you have documentation, data quality, all this in details you can have the view. Then also finally we have vocabulary where you can search different vocabularies inside from the Prometheus software, right? So I think I have almost covered what I had to cover. With that, let me now hand over to back to the team. Thank you so much. Yes, back to you.
Okay, thank you so much. So Bartek, Sarah, and Sajjan, thank you so much one more time for your presentation, especially for showing us the Prometheus Analytics platform. We have 5 minutes left to the end of the meeting, so now I would like to invite our participants to discuss and ask questions to our guests. So please feel free about it. So maybe I start with from my simple question. If you can summarize if in a few words or a few sentences, what makes Prometheus platform different from other real-world evidence platform? I mean, what are the main benefits for its users? Sajjan, maybe.
Yeah, I'll answer
Yeah,
that one. Yeah, so John, feel free to sort of interject as well. Yeah. No, essentially, so what we built Prometheus to essentially be this enterprise grade application. So as I mentioned in my slides, was that we are part of this open scientific community, and so a lot of the tools there that were built as part of the development of the common data model, that is OMOB, they're all open source tools, which is fabulous, which means theoretically anybody can come in and learn how to convert data to OMOB, to utilize the converted data, and to do their own research. But obviously they're open source tools, and they kind of do the job to a certain degree. But what Prometheus does is that we have essentially taken one of those tools, which we actually developed ourselves in the first place, and it's we've essentially sort of added that sort of enterprise grade sort of wrapper to it. So what it does is that it is sort of enhancing that cohort building potential. It has those, as Sajjan showed, those AI accelerators in there, which is obviously speeding up a lot of the more manual process. So for anyone that has done a traditional observational study, they can take quite some time, because obviously just building that protocol, building the cohorts, building the concepts that you need, the inclusion, the exclusion criteria. And even if you're doing that, trying to replicate a publication, as Sajjan showed, you're looking at an awful lot of time, and you're looking at very deeply skilled individuals, teams that need to be able to do it. So you're looking at researchers, data scientists, you need the epidemiologists, but then also you potentially need those data engineers who understand the real world data. So that's a huge amount of team, huge big team, number of people, also huge number of skills required. Prometheus essentially is taking that and almost sort of making that a lot more efficient. You still have that human element. You still need to, at least understand what it's trying to do. And you still got to sort of tell it what to do. You still got that prompt engineering. You still got to be able to understand what it's actually pulled in. Is that correct? But it's all still contained, so it's only going to be looking at the data that you have, unless you open that up across your network and say you're part of a hospital network. You can then actually sort of layer that on top of other data sets that you actually have access to. So what Prometheus does is it sort of then takes that to the next level. So it can be used as a large network platform, but it can also then just be used in your own sort of individual site specific location and do those advanced analytics. And it has all those other features of the cataloging, so you're able to actually create those profiles of the data you have. It just sort of brings in so many elements into one application, but it's sort of almost reducing that need for the clinical expertise, the clinical coding expertise, I should say. So because previously we would actually be having to use those codes, designing those codes, pulling in those codes manually. And as I mentioned, that takes an awful lot of time. So yeah, it's helped sort of speed that up, but it's helped also to then connect potentially other networks, other sites, other data that you wouldn't ordinarily have sort of like access to.
To sum up, to summarize, what is the main target user of the Prometheus platform? Is that the researchers, hospitals,
it's mainly researchers. Yeah, it is the hospitals for sure, because it's normally implemented within sort of the hospital healthcare sites themselves. It's the providers as well. Obviously, our clients are generally sort of the pharma organizations, but again, are the hospitals, because if you're in a hospital and you're part of, say, even a hospital network, you may well want to sort of understand or do some analysis across your network site. So yeah, it's really the researchers, it's the health economics team, it's the epidemiologists. So yeah, those are sort of our main sort of, I would say, users for something like Prometheus.
So how do you think the real-world evidence will develop over the next few years, in your opinion?
Well, something that we've certainly seen across sort of I've been part of this open scientific community for a good 10 years. And so what I've certainly seen across that time is, the expansion of data being accessible. So that doesn't mean that we're now suddenly sharing data with organizations that we weren't allowed to previously. There's still those governance processes in place. Using something like a common data model, a unified data model, enables you to be able to then use other data sets to even potentially even question, to analyze it, but even from afar, never even touch that data. So that's expanded hugely over the last 10-15 years. I think thinking the next 5-10 years, that's going to continue. That availability of being able to access global real world data will increase. I think tools like Prometheus and even the use of other AI capabilities, being able to actually access that data without having huge teams of your clinical ontology experts, your scientific experts, means that you can actually do a lot of that sort of quicker. There's a lot of that learning that is sort of enabled and a lot more efficient. So I think things are just going to expand further. There'll be more data available, and then what that means from a research, academic, scientific perspective, that we'll be able to understand a lot more about the patient, about healthcare, how it's being utilized by the population, by patients. And then ultimately, which is what all of this is about improving patient care, improving patient outcomes. And through that's through data, that's through research, and it's tools like this, it's methods like this that is there to sort of help with improving that.
That's great. So what are your development plans for the next few years in the area of real-world evidence, federated data networks, and also Prometheus platform?
Yeah, no, absolutely. So Prometheus, we are working with our clients directly. So obviously they're using it, but they want to see a lot more sort of added features to it. So obviously the AI element, we are continuing to expand, and we're adding new features. If anyone is really sort of feeling the burn of oh my goodness, this would be amazing if you added, A, B, C, let us know. That would be fantastic. But we're continually improving Prometheus itself. As I mentioned, the federated data network, that is something we are actively building here right now. So we are looking to bring more data partners in. So what I do as part of my day job is actually to talk to potential data partners and say, hey, if you've got health data and you want to essentially make that sort of return on investment of your data, we can help you to standardize that, harmonize that, and then help you to get that sort of return on investment of your data. Or maybe you have data and you want to do more research across your own hospital network or across somebody else's network. It's about expanding that sort of network. So we're expanding the federated network, and there's other tools, other sort of methods that we are continually sort of looking to develop and further as well. So it's all within the real world space. It's all about better utilizing the data and helping to educate those that do have data what they can actually glean from that and how that can actually help with, generating more real world evidence.
So at the end of the meeting, let me ask you about the potential partners. So what kind of cooperation are you looking for in Poland? What type of partners would be most valuable for you for developing federated real-world evidence projects?
Basically, anyone who actually has data and is looking to sort of leverage that further. So, you could be, for example, a partner within a hospital. You may have sort of claims data. You may have sort of registry data. You may have sort of even just sort of like, academic research data. As part of our federated model, we are looking to partner with any sort of data partners, because what we're trying to do is essentially answer and help our clients who are looking to undertake any form of study. So that could be an observational research study looking at patient pathways or burden of disease, but then it could be, for example, clinical trials as well. So or omics data. We're looking for partners, any partners who are really have data, good quality data. Doesn't have to be standardized to this common data model just yet. We can help support with that. We can do that for you. We can even teach you how to do that. But then once you've got that, then sort of being part of our network means that we can then approach you at any point when we've got a study and we said like, hey, do you want to be part of this? This is the study. Your data is going to be great for it. And then essentially you're part of that network. So basically, in short, if you've got data and you want to utilize it more and you want to essentially get a return on investment from it, talk to us. We would be more than happy to have you as a data partner.
Sarah, thank you so much.
Thank you.
don't see any other question. So our guests today were Sarah Seager, Senior Director of Business Development. Thank you so much. Bartłomiej Kosiba, EPAM Kraków Site Lead. Thank you, Bartek. And Sajan Madapadi, a Lead Scientific Curation Specialist. Thank you so much for taking part in the Life Science Innovation Breakfast. And at the end of the meeting, I would like to invite to the next Cluster Life Science Kraków Breakfast. At the next week, we will meet with the Medican Lab company, and we will talk about preparation of medical devices for conformity assessment. You can find more details about the meeting at our lifescience.pl website. Thank you so much one more time, and I wish you a good day. Thank you.
Thank you.
Thank you
Thank you
very much. Thank you all.